Hello everyone, thank you for joining me in today's virtual presentation at BIM Coordinator Summit. I'm excited to guide you through the topic of data-driven BIM for cost estimation, open standard and Power BI. Before we delve into the presentation, allow me to introduce myself. I am Idriss Tchaheu, a software engineer, BIM specialist and trainer with a great interest on BIM technology and process, which is revolutionizing the construction industry for more than 20 years. I'm finishing my BMA Plus European Master in Building Information Modeling. As one of the workers of digital technology and consultancy, my focus has been on developing information requirement, BIM models, and training professionals. I am an Autodesk certified professional for Revit structure. In 2022, I won with a colleague the EU BIM for Building Revelation competition. Also, in 2021, I won with colleagues the second prize of a BIM competition across Africa launched by BIM Arambe Africa. Our presentation will comprise four main steps. Firstly, as an introduction, we will highlight the shift of the construction industry from design-driven BIM to data-driven BIM. Then we will propose a methodology to perform cost estimation using open standard and data analysis and visualization tools Power BI. Moving forward, we will present the implementation and result. At the end, a conclusion will be provided to present the essence of this presentation. Building information modeling has revolutionized the AAC industry by enabling the collaboration among all project stakeholders. In the early days of BIM, its primary focus was on creating and utilizing detailed 3D model as visual representation of building or infrastructure. BIM has evolved beyond simply creating 3D models. It now serves as a central repository for comprehensive building information modeling, accessible using parametric objects. This shift represents a transition from design-driven BIM to data-driven BIM. Two questions are asked by a client when considering an investment in the construction, which are how much and how long. The first question regarding the cost will be answered using BIM technology during this presentation. Knowing that BIM significantly reduces the amount of time and effort for quantity takeoff and cost estimation, and that it also increases the accuracy. Our interest will be focused on using open BIM approach, which is supported by open standards such as IFC and IDS, enabling a transparent workflow among project members who are not obligated to adopt specific software. The Information Delivery Specification Standard IDS allows the definition of information requirement for BIM models. It enables the validation of alphanumeric information to any IFC model produced from any software and has the particularity of being both human and readable. Our interest will be focused on using open BIM approach, which is supported by open standards such as IFC and IDS, enabling a transparent workflow among project members who are not obligated to adopt specific software. The Information Delivery Specification Standard allows the definition of information requirement for BIM models. It enables the validation of alphanumeric information to any IFC model produced from any software and has the particularity of being both human and machine readable and interpretable. The methodology adopted for this workflow begins with the definition of information requirement using USBIM. The methodology adopted for this workflow begins with the definition of information requirement using USBIM editor, where the specifications are written and available both in human and machine readable formats. With the requirement available in the human readable format, Revit is used to create the 3D model in conjunction with Dynamo, where the metadata required from the specification are inserted in the BIM model. After the completion of the 3D model, the model is exported to the IFC format using appropriate setting to export user-defined properties and classification. After this step, the IFC model is imported into the free online Building Smart Validation Service platform to perform the checking of the IFC model regarding the IFC standard. After the first check within the Building Smart Validation Service is performed, the IFC model and the IDS file specification are imported into the open source free software called Blender BIM to perform the validation of the model regarding the requirement, which are the alphanumerical requirement. The validated IFC model regarding the requirement is imported into the Speckle web space platform. Once the model is available inside the Speckle environment, we import it into Power BI visualization tools, and we also import the unit cost of each item available in an external Excel file. Then, functions of Power BI are used to query the information and perform the quantity curve and cost estimation. Coming up to the implementation of the methodology, we start with the definition of requirement through USB IGS editor using fastest. Coming up to the implementation of the methodology, we start with the definition of Coming up to the implementation of the methodology, we start with the definition of a requirement through USB IGS editor using facets of the IGS standard. The type of metadata requirement in the left side are mapped to their corresponding facet in the IGS standard in the right side. In practice, the IFC class and predefined tab are mapped to the entity facet. Then the IFC name and IFC object tag within our model are mapped to the attribute facet where the naming convention will be checked using regex pattern. The requirement regarding the material are mapped to the material facet. Also, the requirement regarding most of the metadata such as location, quantity, dimension, and many others property are mapped to property facet. The requirement regarding the classification in our case, which is the new rule of measurement, is mapped to classification facet. After the definition of the specification, we obtain the IDS requirement in both human and machine readable formats. On the right side, we have the human readable specification for the wall in the BIM model. Now, we also have the machine readable specification for the words in the XML language at the right side. Once the specifications are defined, the BIM model is developed with respect to them. Autodesk BIM interoperability tool is used to define a classification based on the new rules of measurement and assign the classification to the BIM model element. As we can see on the image, some classification to different BIM model elements within the Revit model. After the definition of the classification to the BIM model element, they are mapped to their corresponding IFC class and predefined type as presented in the different image. After, Dynamo is used to automatically create IFC name and object type parameter, then copy the type of each family and paste into IFC name parameter. Also, copy the family name and paste into IFC object type parameter as presented in the image. Other metadata requirements such as concrete grade, exposure class, fire rating are embedded into the BIM model as presented in the image. Once all the metadata are imported to the IFC model, once all the metadata are created in the BIM model, export option is used to organize the user-defined property set and classification within the IFC model. As presented in the image, we have the mapping file of user-defined data to property set and also the mapping for the classification. Once the IFC model is exported from Revit, it is uploaded to Building Smart Validation online platform to verify the conformity of the IFC model regarding the IFC standard. After, the IFC model and the IDS specification are imported into Blender BIM to perform the alphanumerical check. The result of the checking of the alphanumerical information regarding the walls was successful as shown in the image. Similarly, the checking regarding the alphanumerical information on roof element and staircase element are correct. Also, the checking is correct regarding the columns and windows. All these successful results means that the IFC BIM model agrees with the requirement provided at the beginning. Once the alphanumerical information are checked, the IFC model is imported into Speckle platform. We can observe property for a particular column selected, such as the name, the dimension, the fire rating, concrete grade value, and also the classification code and description. The IFC model into Speckle is imported into Power BI using the URL link of the model. After this step, the IFC class and name are extracted and the other property regarding the quantity and classification are extracted in the same way. The unit cost of each item defined in our Excel sheet is imported into Power BI and grouped with the other data already present in Power BI as illustrated in the right side image. The quantity of each IFC class element for the overall project are presented within a column chart. Also, the quantity of each IFC class element for the underground floor level of the project are presented in the column chart. Similarly, the quantity of each IFC class element for the ground floor and the first floor level of the project are presented. The quantity of each element based on the new rules of measurement codification for the overall project are presented within a column chart. Also, the quantity of each element based on the new rule of measurement codification for the underground floor level of the project are presented in the column chart. Similarly, the quantity of each element based on new rule measurement codification for the ground floor, first floor of the project are presented in the column chart. The cost estimation of each element belonging to the underground floor level are presented in the table, and also the overall cost of the underground floor level is also presented. Similarly, the cost estimation of each element belonging to the first floor level are presented in the table, and also the overall cost for the first floor level. Finally, the overall cost estimation of all the elements belonging to the BIM model is provided. The workflow objective was to perform the early stage cost estimation using Open BIM standard and data analysis tools, Power BI. The key step was model validation to ensure the accuracy and completeness of the BIM model using IFC, IDS, and Building Smart Validation Service based on defined information requirement. The workflow also involved the data extraction, where relevant data, including quantity, are extracted from the validated IFC model, data coming from Speckle, and import into Power BI. The cost was calculated by multiplying the quantity from Power BI with unique costs from an Excel spreadsheet. Data visualization and analysis purpose was highlighted by utilizing Power BI to visualize cost data, enabling informed decision making. Thank you for your attention.